Today, we're taking a look at a group of animals that essentially looked at the biological skill tree and just dumped every single evolutionary point into extreme high-altitude survival. We're talking about the Caprinae subfamily, mountain goats, wild ibex, basically the absolute apex cliff dwellers of the natural world. We're going to break down exactly how these precipice lords maxed out their stats to conquer environments that would instantly crush almost anything else. To really grasp what we're dealing with here, picture this. You're staring at the masonry face of the Cingigno Dam in northern Italy. It's a sheer, nearly vertical wall stretching up 160 feet, or about 49 meters. And just casually standing halfway up this man-made cliff face, totally defying the laws of physics, is an alpine ibex. They just wander right across a 70-degree incline with this absolute, staggering nonchalance. And here is the best part. They aren't even pulling off this death-defying stunt to escape a predator or anything. They're literally just hanging out up there because the curing concrete of the dam exudes a very specific calcium-aluminum mineral called candelot salt, or ytternite. Because their alpine diet is severely lacking in essential minerals, especially in the spring, female ibex exploit these microscopic protrusions in the stonework just to get a quick salt snack, driven by pure biological necessity. But to understand how they can casually pull a move like this off, we kind of have to look back at their deep lore. The lore of these cliff dwellers starts way back in the late Miocene epoch, somewhere between present-day Tibet and Mongolia. From this ancestral stock, the lineage split. By the mid-Pleistocene, the true goats, the genus Capra, made their appearance and radiated all across Eurasia and Africa. Meanwhile, the ancestors of the North American mountain goat crossed the Bering Land Bridge. Now, fun fact here, despite the name, the North American mountain goat diverged so early on that it isn't even technically a true goat. It's the only living species in its own genus. Back in the Pleistocene, they actually had a smaller sister species called Harrington's mountain goat roaming the American Southwest. But when the climate dried out and the megafaunal collapse hit, Harrington's goat vanished. That left the modern mountain goat totally isolated up in the glacial alpine of the Rocky Mountains. To survive freezing temps and desperate oxygen starvation, or hypoxia, they didn't just adapt, they evolved some wild passive buffs. If you compare wild caprins with sheep or cattle, you'll see exactly what I mean. While we humans have to slowly acclimatize to thin air, goats permanently bypass that whole process. They rock a baseline heart rate of 85 beats per minute, possessing inherently high hemoglobin concentrations alongside a superior lung diffusion capacity. They're literally built to deliver oxygen perfectly during explosive muscular exertion, with zero acclimatization required. And then there's the cold. To survive sub-zero blizzards, they wear a dense inner wool layer underneath 8-inch hollow guard hairs. But they also come with a built-in heat source. Their stomach, the rumen, acts as a literal biological space heater. They eat incredibly tough, woody browse and lichens. As symbiotic microbes break down all that cellulose, it triggers a massive exothermic composting reaction inside their bodies. So they're practically running an internal furnace just to stay warm. With their internal physiology entirely maxed out, let's look at their mecha-level mobility tech. Engineers use a term called situated heuristics to describe this. Basically, the intelligence is built right into the physical mechanics themselves. A goat's hoof is divided into two highly mobile digits that spread into a V-shape to pinch rocks. The outer edge is made of incredibly hard keratin to catch microscopic ledges, while the inner pad is this soft elastomeric material for massive friction. The joints in their legs passively twist and flex to adapt to uneven terrain. This initiates a stick and slip dynamic, acting exactly like organic anti-lock brakes. The hoof arrests slippage automatically, without the goat even having to think about it. When it comes to actually scaling a vertical face, their muscular kinematics are flawless. They have a low, forward-shifted center of mass. If you look at a frame-by-frame breakdown of their vertical gallop, it's pretty wild. First, they tuck their front legs tightly to their body. Next, they forcefully extend their heavily muscled hind legs. Because their center of mass pulls them forward, they don't experience any backward torque at all. All that kinetic energy just rockets their torso straight upward. This design is so mechanically perfect that bio-inspired engineers actually ripped this exact V-shaped dual-digit hoof blueprint and slapped it onto quadruped robots. When they tested these robotic hooves out in challenging terrains like thick mud, it completely slashed the mechanical cost of transport and boosted the robot's overall speed by an incredible 55%. But having all these overpowered stats doesn't mean they live a peaceful life. Their daily existence is essentially a series of high-stakes boss battles, starting right from birth. When they're born, the kids are highly precocious, meaning they can stand up in just 5 minutes. At first, mothers use a hider strategy. They stash the newborns in rocky crevices while they forage to minimize predator detection. Over time, they transition to a follower strategy, where the kid joins the herd out on the sheer cliffs. Nubian ibex mothers even use natural topographical traps, basically steep-walled accidental canyons, as creches to stash their kids until they're strong enough to climb out. It's a brutal but really effective nursery. And within the herds themselves, adult females are fiercely dominant. Female mountain goats have some of the highest rates of goat-on-goat combat, or intraspecific aggression, recorded in hoofed mammals. They battle viciously with dagger-like horns just to get access to the scarce, high-quality forage they need for lactation. And then you have the external threats. Cougars and snow leopards are constant dangers, but the most cinematic threat actually comes from above. Golden eagles are obviously too small to just pick up and fly away with an adult goat. So instead, they execute this highly calculated, brutal physics matchup. The eagle swoops down, locks its talons into the goat, and intentionally drags it off the cliff edge. It weaponizes gravity against the goat, perfectly countering the animal's absolute grip with raw, sheer dropping force, and then just glides down to the valley to feed. Yet, despite apex predators pulling wild moves like that, the most indiscriminate killer they face is the mountain itself. Recent long-term studies have revealed a staggering environmental truth. Avalanches are actually their leading cause of death. Depending on the region, avalanches account for 36 to 65% of all mountain goat mortality. And unlike starvation or disease, which usually target the weak, avalanches wipe out prime-aged adults entirely at random. The tragic irony here is that the steep avalanche chutes are the very first places to clear of snow and sprout fresh spring forage. The goats willingly put themselves in this deadly line of fire just to get vital nutrition. Wrapping up their story, we have to look at their collision with human history. These animals have always existed on the very edge of the human world. For thousands of years, their ability to thrive in these totally inaccessible fortresses made them an enduring symbol of grace and survival. In the ancient Near East, the Nubian ibex was a deeply familiar sight in places like the En-Gedi Oasis. Ancient scripture references them pretty often. Psalm 104 famously states, "The high mountains are for the wild goats." They served as this powerful visual metaphor for divine provision, basically showing that even the most barren, punishing environments on Earth had a purpose and sustained beautiful life. They also held immense ritual importance. In the Second Temple era, the primary shofar blown to mark the Jewish New Year was fashioned explicitly from the straight horn of Yael, or ibex. It was overlaid with a gold mouthpiece and flanked by 2 silver trumpets. The straightness of the ibex horn wasn't just an aesthetic choice either. It highly symbolized straight, unbending prayers ascending directly to the divine. Fast forward to the modern era, though, and that historical reverence turns into kind of a sci-fi tragedy. The Pyrenean ibex, or bucardo, was completely decimated by human hunting. By 1999, only one single female named Celia remained. Biologists took her cells and froze them. In 2000, Celia was crushed by a falling tree, rendering the subspecies officially extinct. But in a landmark endeavor in 2003, scientists used nuclear transfer to clone Celia. A cloned female bucardo was born, making it the very first time in human history an extinct animal was brought back to life. Tragically, the clone had a massive lung defect, a fairly common flaw in early cloning, and it suffocated just 10 minutes later. The Pyrenean ibex holds the grim record of being the only animal to ever go extinct twice. Now, contrast that multi-million-dollar genetic resurrection effort with the grim reality happening right now over in Ethiopia. The Walia ibex is completely endemic to the Sinaian Mountains. And today, due to armed conflict, poaching, and severe habitat degradation, there are barely 271 individuals left alive on Earth. It really leaves you with a heavy thought. We've reached a point where we have the literal technology to resurrect a ghost, even if it was just for 10 minutes. So why is it so incredibly hard for us to protect the 271 stats-maxed evolutionary marvels that are still breathing right in front of us? It's a striking contradiction about how we treat biology's ultimate survivors.
What the fact? Follow for more.